Okay, let's look at the last example. This is a very important example of that has got all equations together. We have a pipeline bends in horizontal plane through an angle of the 45 degrees. You can see here is a completely horizontal, so there's no weight applies to that. So the diameter changes from 0.6 before the bend to 0.4 after it. So it's just reducing from 0.6 to like a 0.4, from 60 centimeters to 40 centimeters. Water enters the band at the rate of the like a 0.5 cubic meters per second. Okay, the flow discharge throughout the pipeline is fixed, half a cubic meters per second, with a pressure of the 150,000 newtons per square meter. Okay, assuming that there's no energy head loss. Okay, so we're just going to need to calculate the force exerted. So the force exerted here, the force in here exactly. And as you know, on the pipe bent by the water. So as you know, the forces are like the horizontal and the vertical elements, or you can just divide it to like the horizontal and vertical elements and calculate each of them separately, and then resultant force can be calculated with the angle to the like the horizontal axis. Okay, so first of all, we're just going to need to just use the continuity equation, then energy equation, and finally the momentum equation to calculate the F. Okay, so first application of the continuity equation. So we're just going to write, we have like a flow rate here, but we don't, and we have the diameters here, and we don't have the velocity. So we just easily calculate or apply the continuity equation. V1 is Q over A. So Q is like a half, 0.5, divided by pi. D1 squared over 4 becomes on the top of the ratio. You know, you can multiply by a half times pi 0.6 squared. Okay, the result is 1.768 meters per second. So it's relatively like the normal velocity, just bear in mind. Again, velocity V2 is calculated the same, like or based on the V1 A1 is equal to V2 A2. Okay, or you can just use it the same, like the relationship of the V2 is equal to Q over A2. It's completely the same. Eventually, the result is V2 is 3.978 meters per second. So to understand this one better, just look at the previous examples here. So, or you can just either use the first approach here to calculate the V2. So this is like the relative high speed. Okay, so the second, we're just going to need to just apply the energy equation to calculate the pressure at the exit. So we have the pressure at the beginning, with the pressure at the beginning, P1, but the P2 is not given. So we need to calculate that one. So the V1 squared over 2G plus P1 over rho G is equal to V2 squared over 2G plus P2 over rho G. So we're just going to substitute everything here. We have V1, V2, we have P1. The only thing that we don't have it is P2. So the last term, P2 over rho G, is like unknown. So once you're just going to solve this one, P2 is calculated here, 143 times 648,000 newtons per square meter. So lastly, we need, before we're just going to go for that one, we know for momentum equation, we need to just have like a force at the beginning and force at the end. Force, you know, is equal to P1A1, we have the P1 and we have the A1, and the P1A1, or the force at the beginning, is like a 42.412 thousand newtons, and the P2A2 is like 18.051 thousand newtons. So the P1A1, P2A2 is calculated. So with that assumption, you're just going to go and apply momentum equation. A standard momentum equation into two directions like X and Y. You're just going to apply for both X and Y. You can just refer to the slides that we discussed about how to calculate the FRX and FRY. We're just going to write everything's here, and the FRX is calculated, for example, in this case, and FRY is also FRX is calculated 29.125 thousand newtons, right to left. So this in this direction, right to left. And FRY, obviously, from the upward is just going to calculate it here. So it's calculated here in this direction as well. FRY is equal to 14.17 thousand newtons. Okay, so once we're just going to have this one, and once we're just going to have that one, we can easily calculate the FR is the resultant based on the Pythagoras, and the resultant force is like the 1,000 times square root of like a 29.125 squared plus 14.17 squared. The result is 32.389 thousand newtons, and the angle of the force is an arctangent of the ratio of the horizontal. It's like a 14.717 divided by 29.125, and the angle arctangent is like a 25.9 degrees to the horizontal. So this is like the angle we're just going to have here. Okay, so that's an example of the momentum equation, or in other words, we just have like the application of all three, continuity and energy and momentum. We just apply a continuity first, then energy equation, and finally the momentum to calculate the external force exerted to the pipe in this direction. So the external force applies in this direction roughly.